Hey guys, welcome to our first video lesson looking at Unit 5 on chemical equations. So if you guys haven't done so already, why don't you go ahead and start setting up your lab notebook and start a new tab and label it Unit 5, Chemical Equations, and I'll give you guys a few seconds to do that. Okay, so starting off the notes for this unit, what we're going to be looking at today is how to balance simple chemical equations. And the goal for today is to differentiate between reactants and products and balance simple chemical reactions. So what we're going to start off talking about today is specifically when we're looking at a chemical reaction, where are the reactants and products, and then we're going to be looking at the whole point of balancing chemical equations is looking at the law of conservation of matter. Okay, so to start off the notes, kind of just looking at the difference between a reactant and a product when we're looking at a chemical equation. Okay, so reactants are what you put in to a reaction. So like if I'm cooking, my ingredients that I'm going to put into something would be like flour, eggs, sugar, chocolate, chips, vanilla extract, etc. Okay, so it's something that you're putting into a reaction. Now your products is what you're getting out of it. So if I put in to a reaction flour, eggs, sugar, chocolate chips, and vanilla, what I'm going to get out of it, my reaction or my reactants are going to be my brownies. Okay, so when we're looking at this chemical equation up here of sodium and bromine together make sodium bromide, the sodium and the bromine, these would be my reactants. And then sodium bromide, this is my products, what I'm ending with. Okay. Now, key thing when it comes to this arrow, okay, what the arrow is representing is not equals. Okay, what it means is yields. Okay, so when you're writing out chemical equations, do not put equals in a chemical equation. That's not what it means. It means yields. Okay, so what I like to think of as like a sentence is reactants react to produce products. Okay, reactants are always on the left-hand side and my products are always on the right-hand side. Okay. So law of conservation of matter. Now this is something that we looked at when we looked at Dalton's laws. Okay, so what it basically states is that the amount you put into an equation must equal the amount that comes out. So nothing can be created or destroyed and atoms cannot be rearranged. So what this really means is that when we're looking at chemical equations, okay, I can't start a chemical equation with having 7 atoms of oxygen and then I'm only producing 5. Okay, that would be destroying some of those chemicals or some of those atoms of oxygen. Okay, key thing about this is that atoms are just going to be rearranged within a chemical equation, and the amount that I start with is going to be equal, okay, to the amount that you end with, which is kind of the whole point of balancing out chemical equations, is because you are looking at that the amount of atoms that you start with at the end, at the beginning of a reaction is the same that you end with at the end. Okay, so now looking at a chemical equation and looking at some numbers that are really important for you guys to understand, because these are numbers that you guys will be looking at when balancing a chemical equation. Okay, the first thing to understand are coefficients. Okay, these are numbers that are in front of a compound. So like your coefficients, this 2 is a coefficient for sodium bromide, and there's another 2 over here for sodium. Now, what these coefficients mean is that there's 2 sodium bromide molecules. That means I have sodium bromide, okay? Same thing over here. This means I have 2 sodium atoms. I have 2 sodium atoms over here, okay? Now, key thing you'll notice in front of the magnesium and the magnesium bromide is that there isn't a coefficient there, okay? Same thing that we did with writing chemical formulas, okay, is that if there isn't a number in front, okay, you assume the coefficient is 1, okay? Very similar to like algebra, okay? In algebra, you don't write 1x, okay? You just write x. Same thing in balancing chemical equations, okay? I'm not going to write 1 magnesium, you just write magnesium, okay? So kind of keep that in mind as we're going forward. Also, what you see in the chemical equation, you see these small numbers here, and we saw these when we were writing out compounds. What those small numbers are called are subscripts, okay? Basically, they're also telling me how many of that given element there is. So it's telling me there's 2 bromine molecules, okay? But the key thing is when we're balancing out chemical equations, the things that get changed are the coefficients. So it's going to be these larger numbers out in front, okay? And also, last thing, when we're balancing out chemical equations, you're also going to be multiplying by the subscripts. So what that means is, let's say on magnesium bromide, I have a coefficient of 3, okay? What that means is that I have 3 magnesium bromides, magnesium bromide, magnesium bromide. Now, when you're calculating out how many magnesium bromide molecules there are, remember this 3 is going to go to every single element in that compound, and if there's a subscript there, then you're going to multiply it by that. So that means that there's 1, 2, 3 magnesiums, and there's 2, 4, 6 bromide molecules, okay? All right, so just looking at some equations, okay, or just some questions. So looking at the exact same equation, it says how many sodium atoms are on the reactant side of the equation. Okay, so remember, this is my reactant side. Over here, my reactants yields my products. Okay, so what I'm looking for in this first question is how many sodium atoms are present on my reactant side of the equation. Okay, and remember, sodium is Na. Okay, so that's what I'm looking at. So I'm looking at my coefficient of 2, and remember that coefficient of 2 is telling me how many of that whole molecule there is. Okay, so over here, there'd be 2 sodium atoms. Okay, so there'd be 2. Same thing, now we're looking at how many bromine atoms are on my reactant side. Okay, same thing as my sodium, this coefficient is telling me how many of that entire molecule there are. Okay, so there would also be 2 bromine molecules. And then the last question is how many magnesium atoms are present on my reactant side. Okay, so here's magnesium. Okay, remember you don't see a number, so you assume it's 1. So there's 1 magnesium atom on my reactant side. Okay, so before we get into a practice example as a class, okay, we're going to be looking at the steps of how to balance chemical equations. Okay, and it's really just a simple 2-step process. Okay, step 1, you're going to determine the number of each element in the reactants and products. So what this really is counting atoms. So what we were just doing on the previous slide, looking at those chemical equations. So you're counting out how many individual atoms there are, looking at your coefficients and subscripts. Then from there, in step 2, you're going to use the coefficients to balance out the number of elements on each side of the reaction. Okay, so key thing here is we're going to be using the coefficients to help balance out the chemical equations. So when we're manipulating different numbers, we're not going to be using those subscripts. It's just those coefficients, which are the large numbers out in front. Okay, and kind of key thing here is remember to multiply the coefficients by the subscripts. Okay, I feel like whenever people go wrong in balancing chemical equations, they always go wrong in this last step here, where either they go wrong in counting atoms or they add the coefficients and the subscripts together. They don't multiply them. So make sure you guys just watch out for that as you're going through different practice problems. Okay, so looking at this practice problem of balancing out this chemical equation of iron plus oxygen yields iron oxide. Okay, kind of a good little hint is whenever you're balancing chemical equations that have oxygen or hydrogen in them, I would leave them to be your last elements that you kind of balance out, simply because they tend to get a little challenging, so I would do other elements first. Okay, so what I always start out by doing is I always draw a line down. Okay, down from the arrow, splitting off my reactants from my product side. Okay, then I just list out the elements that are on each side. So on each side, I have iron and I have oxygen. Okay, then what I do is I just count my atoms for my reactants and my products. So on the iron side, okay, over here on my reactant side, I have 1 iron atom, and over here, okay, remember that subscript of 2 is telling me that there's 2 oxygen. Then over here, looking at my iron oxide, I can see that there's 2 iron, and this subscript of 3 is telling me that there's 3 oxygen. Okay, so step 1, sorry if you guys can hear my dogs. So step 1 of counting out the atoms is complete. Okay, but now the whole point of balancing equations is the number of atoms on my reactant to product side, they need to be the same. Okay, so I'm going to go ahead and change some of the coefficients to start balancing that out. And the easiest thing to start with is with the iron. Okay, so I see I have on my product side, I have 2 iron atoms. So I'm going to add in the coefficient of 2 in front of this iron. Okay, and this now changes this to 2. Okay, so now my irons are balanced. Now, looking at my oxygen. Okay, my oxygen on my reactant side I see is going to increase by multiples of 2. And then my product side I see is going to increase by multiples of 3. Now here is where I need to think, okay, what can I multiply them both by? Like the lowest number I can multiply them by and get the same thing. Okay, and that would be 6. Okay, because I know 2 times 3 is 6 and 3 times 2 is 6. Okay, so I'm going to go ahead and do that on my reactant side. I'm going to put the coefficient of 3. Okay, remember when you put a coefficient out in front and you have a subscript there, you multiply. So 3 times 2, I now have 6 oxygen atoms over here. And then to get 6 on my product side, I'm going to put a coefficient of 2. Okay, so that means, remember this coefficient is going to go to every single element in that compound. And if there's a subscript there, then you're going to multiply. So that changes the 2 times 3 for my oxygen, that changes it to 6 as well. But notice, when I put that coefficient of 2 there, that also changes my iron to 4. Okay, which is totally okay. And you're going to notice when you're balancing chemical equations, I kind of like to think of it as like a ping pong game. Okay, you're going to be going back and forth, changing these coefficients a few times, okay, just to make sure that they're balanced. So now I need to go over to my reactant side because now my irons are off. Okay, and I need to think, okay, what would I need to put, what coefficient would I need to put in front of that iron to get it to 4? Okay, so I would need to put the coefficient of 4. Okay, so you're going to go ahead, put that in, and that changes that to 4. Okay, so then the coefficients for this balance equation is 4, 3, 2. Okay, and also kind of like a good rule of thumb is you're always going to put coefficients out that are the least common multiples. Okay, so if you're ending with something that could be reduced, then I would go ahead and do that. Okay. So if you guys have any questions, feel free to leave them in the comment section or go ahead and write them down in your notebook, and be sure to ask them in class. And I will see you guys tomorrow.